How do magnets work? No glue, no hands, no magic. Even scientists find them hard to explain. Richard Feynman said so. I'll try anyway, in a way a 7-year-old can understand. Everything is made of atoms, right? Atoms have tiny particles called electrons spinning around them. Here's the cool part. Each spinning electron is like a teeny tiny magnet itself. We're talking really small, millions of times smaller than a grain of sand. In most stuff like wood or plastic, these tiny magnets point in random directions. One points up, one points down, one points left. They cancel each other out. No magnetic power. But in iron and some special metals, something different happens. When all those tiny magnets line up and point the same direction, boom, their powers combine. It's like one person can't push a car, but 100 people pushing together? Easy. Billions of tiny magnets all pushing together equals one strong magnet. Every magnet has two ends called poles, north and south. Here's the rule. Opposites attract. N loves SAT. They want to be together. But same poles, N and N, they're like, get away from me. They push each other apart. Magnets have an invisible force field around them. You can't see it, but you can see what it does. Sprinkle iron filings near a magnet and watch. They arrange themselves in beautiful curved lines. That's the magnetic field. And here's what's crazy. This field goes through stuff. Paper, your hand, wood, the magnetic field passes right through. That's why you can move a paperclip through a table with a magnet underneath. The field doesn't care about walls. Why does a magnet stick to your fridge but not to a wooden door? It's about those tiny electron magnets we talked about. In iron, nickel, and cobalt, the electrons are cooperative. They want to line up when a magnet comes near. But in plastic, wood, or your hand, those electrons are stubborn. They refuse to line up. The magnet is like, hey, line up, and the electrons are like, nah, we're good. No lining up equals no sticking. Pro tip, steel sticks to magnets because steel is mostly iron. But aluminum? Nope. Copper? Nope. Gold? Nope. Only iron, nickel, and cobalt are truly magnetic. Now you know more than most adults. Here's something cool you can try at home. Take a regular iron nail and rub it with a magnet, but always in the same direction, like 50 times. You're forcing all those tiny electron magnets to line up. And guess what? Your nail becomes a magnet. But be careful. If you drop a magnet hard or heat it up, you can mess up that perfect alignment. The tiny magnets get jumbled again and poof, weaker magnet. That's why you shouldn't bang your magnets around. Want to know something amazing? Earth itself is a giant magnet. Deep inside Earth's core, melted iron is moving around, creating a massive magnetic field that wraps around the whole planet. That's why compasses work. The little magnetic needle in a compass is attracted to Earth's magnetic North Pole. Explorers have used this for thousands of years to find their way. Your fridge magnet and Earth's core? Same basic physics. So magnets aren't magic. They're billions of tiny electron magnets working as a team. Next time you stick something on your fridge, remember, that's atomic-level teamwork right there. Pretty cool for a little piece of metal. If magnets make more sense now, subscribe for more explained like your 7 feet videos. Missed the gravity video? Check it out. Links on screen. See you there.